Hello everyone. If you're watching this video because you were absent from class or you missed something in the notes or you're just reviewing, you might want to have your packet in front of you so that you can copy down the notes as we go through them. If you're not in my class and you don't have a copy of these notes and you want one, you can email me or you can stop by my classroom at school. Um, or you can just take a screenshot of things as you watch them. But what we want to do is we're going ahead and we're starting our first unit of the semester about the mole. And you might be wondering, are you talking about one of those furry little animals that's in the ground? And I'm not. The mole is another unit of measurement that chemists use. But before we get to that, we kind of want to go through a dimensional analysis review. We learned about it last semester when we were doing metric conversions, and we're going to be doing it a lot over the next semester. So we want to make sure that we go through a few things. Now remember, with dimensional analysis, we've been using this for metric conversions. And when we've been using metric conversions, we have been using the prefixes that go along with them. So kilo, hecto, deca, a base unit, which would have no prefix, deci, centi, and milli. Now, as a reminder, your base units are dependent on what type of measurement you're making. So for example, we might use the base unit of a gram for mass, meter for distance, seconds for time, and liters when we're talking about volume. And obviously if we add any of these prefixes before them, we could have a milliliter or a centigram or a kilometer, right? Or a kilometer, depending on where you're at and how you want to pronounce it. But the key thing here is that when the way to memorize the order that the prefixes go in is that King Henry died by drinking chocolate milk. Now, with kilo, king, starting with a capital K, we know that the units down here, kilo, are going to be large, and milli is going to be referring to a very small number. And what you need to do is you need to look at some practice problems. So if we look at A, it says how many centimeters are in 4.3 decameters. So the first thing you're going to do in a dimensional analysis is you're going to write down what's given to you in the problem. So we have 4.3 decameters, and the symbol for dA is dA, and meters is an M, so it's DAM, and you're going to put that into this T-chart. Now you can leave this bottom square blank, or you can put a 1 over it. It doesn't really matter. I usually leave it blank because chemists are lazy and we don't write ones. Why write unnecessary things? And whatever your unit you have in this top section here should also appear in the bottom right corner. So I'm also going to put decameters down here. And I'm going to put the unit I'm looking for or trying to convert to on the top. So I'm trying to convert to centimeters. Now what we'll do is I'm going to highlight decameters and centimeters, where we have and where we're going. Now when I do this, deca is 1, 2, 3 spaces away from centi. And what you'll do is you'll put a 1 next to the prefix or unit that's larger. Now deca is larger than centi, so I'm going to put a 1 here. And I'm also going to put a 1 by the centimeter, but what I'm going to do is I'm going to add 3 zeros next to that 1. And the reason why I chose 3 zeros was because there are 3 spaces between deca and centi. You see we move from deca to base, that's 1, base to deci, and then deci to centi for 3. So 3 zeros, 3 spaces. And what this tells us is that 1,000 centimeters is equal or the same as 1 decameter. And so now we have what we're looking for. Now when we do the math for this, decameters is going to cancel out with decameters. That's why we have 1 on top and 1 on the bottom. and you multiply the numbers that are on the top and you divide by what's on the bottom. So in your calculator, this would look like 4.3 times 1,000 divided by 1. Now obviously there's no real reason for dividing by 1. It won't change your answer, but you want to get in the habit of knowing what you should do. And so when we do 4.3 times 1,000, we get 4,300 centimeters as our final answer. Okay. Now, what if we were to do one like C, where it's going from a smaller unit, milliliters, to decaliters? Well, again, we start off with what we're given, 1,000 milliliters, and we put the unit that we have on the bottom right. So we're going to put milliliters on the bottom and decaliters, the unit we're looking for, on the top. And we know that deca is larger than milli, so I'm going to put a 1 next to decaliters, and I'm going to put a 1, and then I need to count the number of spaces I have. So I'm going to use a different color highlighter. I'm going from milliliters to, I'm going to count the spaces. So there's 1, 2, 3, 4 spaces between milli and deca. So I'm going to add 4 zeros next to the 1 because it's a smaller unit, and that's 10,000. So I'm just going to put a comma there so that I can clearly see it. And when I do this, my milliliters, I have 1 milliliters on top and bottom. And the way that this would be put into the calculator would be 1,000 times 1 divided by 10,000. Now, when we do this, we will get 0.1 decaliters. And the reason why we know decaliters is that's the only unit we have left. Okay, so those are going to be our 2 examples. You can do the other 2 at home for practice. In order to compare your answers, for B, you should be able to get 3.5 times 10 to the 6 decagrams. This would also look like 3, 5 with 1, 2, 3, 4, 5 zeros after it. Those are the same number. And for D, you should have 4.56 kilometers. Make sure that you get practiced with being able to put numbers that are in scientific notation into your calculator. If you need help with that, please come ask, because using your calculator correctly is extremely important. Now, I have another video on this playlist that's called Molar Mass Basics, but I just want to go over this example so that you know exactly what was going on in class. So with these next problems, molar mass is by definition the amount of mass in 1 mole of a substance. Now that substance could be an element, it could be an ionic compound, it could be a covalent compound, it could be marshmallows, it could be anything. A mole is just a unit that we use, and we'll go into that more later. But molar mass and being able to calculate it is a very basic and very fundamental skill that you need. So with this, it also gives you practice with going from the chemical name to the formula. So remember, for sodium phosphide, okay, sodium is Na and has a +1 charge because it's in column 1. Phosphide, the IDE tells you that you're looking for an element on the periodic table, specifically a nonmetal that starts with phos, and it's talking about phosphorus, which is in column 15, so it has a -3 charge there. And because we have a +1 and a -3, you have to cross and drop, which results in Na3P. Now remember, the 1 is not written as a subscript P because chemists are lazy. We don't really write 1s. And if you look at the sample problem over here, for sodium, there's a 3 here because that's a number of sodiums that we have in our formula. So you can see that being able to write the correct formula from the chemical name is going to be crucial for this molar mass calculation. And we have 1 phosphorus. Now, these numbers here, these are the atomic mass from the periodic table. So if you're thinking about a box on the periodic table, you know that, for example, if we were to look at carbon, okay, carbon is number 6 on the periodic table, and it has an average atomic mass of 12.011, or you might just see 12.01, depending on how many decimals your periodic table goes. And this not only is measured in atomic mass units, but it is also the number of grams in 1 mole. So that's saying that 1 mole of carbon is equal to 12.011 grams of carbon. Now, this is useful to us because even though we don't know the molar mass of sodium phosphide, we can use the periodic table to help us figure out the molar mass of its individual components and then add them together. So if I have 3 sodium atoms, and each sodium atom has an average atomic mass of 22.99 grams, then 3 times 22.99 gives me 68.97, and 1 times 30.97, which is the average atomic mass of phosphorus, equals 30.97, and then I add those two numbers together to get my final answer of 99.94 grams per mole. And so if we were to do another problem, for example, number 2, magnesium nitrate, we know that magnesium has a symbol of Mg, and it has a +2 charge. Nitrate, that ATE, tells me it's a polyatomic on the back of our periodic tables, and nitrate is going to be NO3 with a -1 charge. Now, if I have a +2 and a -1, I do have to cross and drop. And when I do so, I will have Mg NO3 2. Now, this is a little bit different. Remember, you're going to need to practice how you count up your atoms when you have a 2 outside of a parentheses. Do you add? Do you multiply? What do you do? The correct answer is that you multiply. So when we're listing out our elements, we have magnesium, we have nitrogen, and we have oxygen. I have 1 magnesium, and I have 2 times my 1 nitrogen, which is 2, and then 2 times my 3 oxygens, which is 6, and I'm going to multiply them by their mass on the periodic table. So I look at my periodic table that you should have in hand, and magnesium has a mass of 24.81, nitrogen has a mass of 14.01, and oxygen has a mass of 16.00. Now, when I multiply these out, I'm going to have 24.81, 28.02, and 96. And then I'm going to add these 3 answers together, and I will get 148.33 grams per mole of magnesium nitrate. You want to make sure that you get in the habit of always including your unit. So the unit in this case would be grams per mole. And you also want to make sure you get in the habit of including what substance it is. Okay, both will be necessary for a correct answer in a practice problem. So what I want you to do is I want you to practice the rest of them. So pause the video, practice the rest, including your formula naming and doing your molar mass calculations, and then you can unpause the video to check your answers to see if you have been successful. Okay, so now let's go ahead and check your answers. You can, I'm just going to scroll through. You can pause as you need to look at the video and then look at your answers. Remember that if you're trying to get a stamp for completed work, all work must be shown. So that includes looking at how you were able to go from the name to the formula, as well as the math required to get these answers. Okay, I just want you to be able to make sure that if you've made a mistake, you can catch it. And so we're going to go into the notes next, but I'm going to do that in another video so that this one doesn't get too long. So make sure you go to the next video for part 2.